Okay, so in this video, we're going to talk about field forces versus contact forces. So I know this diagram says that gravitational force discussed earlier, but we'll just use this as the example. So when we talk about gravity, okay, it's an example of a non-contact force, right? So gravity doesn't touch us, okay? It comes from somewhere, okay? And then the group of these forces are what we call field forces. And what happens is it comes from this field that surrounds, let's say, for example, the Earth. Okay. Now you just can't really say Earth for every situation. Yes, most of the problems will involve Earth, but you may find that rare example just talks about like Mars or Jupiter or some random place in the universe. So basically, what happens is we have a central object, and then we have this field, this gravitational field that's directed towards the center of the central object. And this is how gravity works, right? Because everything falls down to the center, right? And so at any point along the line, right, an object that sits in this field wants to get pulled down to the center. So if I have, let's say I have an object way out here, it wants to get pulled towards that center, okay? But again, the Earth or the central object is not touching that object that sits in that field, okay? And there's a field strength at any point in time, okay? We call it, when we say that acceleration due to gravity, well, that gives us our field strength, okay? And you'll see this formula pop up later, okay? Where the gravitational field is measured in newtons per kilogram, okay? That's just another way to say, it's this many newtons per kilogram of the object, okay? Some of the examples of field forces, okay? We talk about the gravitational force, right? And notice I'm not necessarily calling it gravity, but it's the gravitational force. We have the electric force is another field force, and then we have the magnetic force is the third field force, okay? These do the last two, electric magnetic, they get lumped together into one big force called the electromagnetic force, and we'll get into that later. Basically, because they behave the same way, they look the same way. You can actually get one. You can get one thing from the other. But as you can see in the next bullet point, I mean, everything has the same basic structure, right? It's a central object causing a force to be exerted on an object, okay? That's how these work, right? So if we have an electric field, we have an electric charge that is surrounding, this object, or we have an electric field surrounding an electric charge, pulling or, attracting or repelling objects, okay? Same thing with magnetic field, right? Or magnetic force. We have a magnetic field that sits around these magnets that's either attracting or repulsing other objects, okay? That's one type of force. The other type of force is what we call contact forces. And most of the forces that we will deal with, especially here in Newton's laws, are contact forces, okay? They're called contact forces because there's a direct touching of objects, or of the object, okay? And now what we're gonna do is kind of look at just a bunch of different forces that we can potentially run into, okay? So the first one is what we call applied force, right? And the symbol is F sub APP. Okay, usually that's what the symbol is. It's just F with the subscript. And this is just it's a force applied by a person or an object. Okay, so sorry, I got the word or. Right, so if I push on a box to slide it across the floor, I'm exerting a force. If I pull on a string, okay, I am applying a force to that string, okay? it could be if I'm in a car and I'm pushing another car, my car is applying a force on the other object, okay, the other car. The second one, okay, is what we call weight. Now I'm going to start this because this is a non-contact force, okay? The symbol is F sub g. That's because it is simply what we break down to be the force of gravity, okay? So this is the physical force that objects experiences when they're in that gravitational field, okay? So you go to the doctor's office, they tell you your weight. What they're basically telling you is the amount of force of gravity that you are experiencing, okay? So the SI unit for force is newtons, but here in America, or the US customary system, the unit for force is actually pounds, okay? Next one is normal, right? What is called the normal force. So F sub n. It's what it really breaks down is it's a support force, right, exerted by a surface. So it's exerted by a surface, and that's the key thing. If you don't have two surfaces that are in contact, there's no normal force. Okay, this is the one force that a lot of students will always try to put onto a free body diagram, but it's not there based on the situation. So if an object is falling, there's no normal force. Okay, and the other thing is it's perpendicular to the surface. Okay, there's a math term called normal. Okay, and that just tells us that it's perpendicular. So if it says to draw a normal to that line segment, you're drawing a perpendicular line to the line segment. Okay, the next force is friction, and this is a force that we will study a lot. Okay, it's a big force. Okay, so it's exerted by a surface on an object that moves on the surface. So exerted by a surface as an object moves on that surface. Okay, so really, I mean, we're going to talk about it further, but there's two types. There's static friction and kinetic friction. Even though the word static means not moving, that's the force that you have to overcome to begin to move. Okay, if you're sliding something or pushing something, there's like that slight tug before it actually begins to move. That tug is the overcoming of static friction. Okay, the next one is tension. Now, we've been neglecting air resistance. Here is where we will not neglect air resistance. Okay, and air resistance is actually a special type of friction. Okay, so then we go back to tension force. Okay, or tension. It's the force on a rope, string, cable, something of that nature. Rope, string, cable, right? The key thing is that these do not get deformed, right? So they're not deformed. That's very important to note. The next one is what is called the spring force. Okay, well, Fs. Sometimes you'll see this as FSP. So this is a force exerted by a compressed or stretched spring. All right, that's what I'm talking. Exerted by a stretched or compressed spring. Okay. Where it really boils down to is these are also elastic materials, right? And most of the time, these the tension is more inelastic, right? We don't want them to deform. We don't want them to stretch or compress. Okay, so in the next video, we're going to really now start diving into Newton's laws. These are just some of the forces that you'll see over the next bunch of videos, especially when we do problem solving.